Welcome back from the land of u-substitution. I don't know if you noticed, but our favorite Feeling Sorry for Ourselves song came on just as the time we started doing u-substitution. Coincidence? I think not. I think YouTube knows you're going to feel sorry for yourself sometimes. You got to get out of that little rut. Okay. So I'm going to go back to another example of u-substitution. Again, another trig function. Trig function, always just got to try. You got to try something, see what works. So, unfortunately, I don't know how to integrate a fraction if I can't change the form of the fraction. I don't have any rule to undo the quotient rule. So, use what you know about trig. Well, cosine squared, 1 minus sine squared. Still have a fraction, though. Oh, well, I can factor this into 1 minus sine x, 1 plus sine x, just like you would factor 1 minus x squared into that. Well, looky here. So we're actually integrating 1 minus sine x. See, I told you shouldn't have been pouting. Should have been integrating. Because that does not take a chain rule. There's no chain rule. No substitution needed. Integral of 1 is x. Integral of negative sine is cosine of x. There you were pouting and singing about everybody who's hurting. Right there. Take the derivative. You get 1. Negative sine. Too easy. Oh, but let's crank this up a little bit. Okay, we're going to this number 5 problem here. So, again, a good strategy when you have a function that's inside of a function. That's a good place to start as substituting. That's where I would start. So you know that's a chain rule, but since I know you can do some chain rules in your head already, we'll see if that works out. So we're going to let the u be the cosine of 3x. Okay? So we take the derivative of u, negative 3 sine 3x, dx. The negative 3 comes from the negative from the cosine and the 3 from inside, d outer and d inner. Okay. Divide by. These steps are the same every time. Find u, try u, take the derivative, solve for dx. Now let's just hope. Hold on. If we plug in, we can substitute and find something that works. Okay? Cosine 3x. So let's write sine 3x, sine of u, because cosine 3x is my u. And then my dx is du over negative 3 sine 3x. Now let's hope something cancels out of there. Well, it looks like I'm going to get something out of here. Sine 3x, sine 3x. So I'm really integrating a negative 1/3. I'm putting that out front. Sine of u du. So I just cleaned it up. The integral of sine is negative cosine. Sorry, integrate. Might as well get rid of the integral sign. Negative cosine plus c. Derivative negative cosine, positive sine. Just double checking that work. So you have 1/3 cosine of u plus c. If you want to save a step, this is a place to do that. Don't write u again. Write cosine 3x. So we have cosine of cosine of. Okay, so this one says extra fun, but don't be scared. This is our first example of some more difficult functions. Again, picking a quantity to let my u substitution. So I'm going to let that be my u substitution. We'll see if this works. You never know if it's going to work for sure until you substitute. It's like a box of chocolates. You never know what you're going to get until you bite into one. Take the derivative. I have negative 2 dx. Solve for dx. First 3 steps every time. Okay, now I want to go over and substitute. So integral x plus 7. This is u to the 1/3. And this is du over -2. Now, unfortunately, we didn't get rid of everything. Nothing's canceling out. But I got a little secret for you, a little trick up my sleeve. And it's called the double substitution trick. So when you get down to here, before you give up on it and start over, say, is there something I could put in here? Could I solve my u equation for x? And I can. I go to this equation. U equals 3 minus 2x. So u minus 3 equals -2x. So x equals u minus 3 over -2. So I can take out x. This is more complicated than you want to have on your first day assignment. That's why it's on the extra fun section. I can take out my x and put in u minus 3 over -2. And you're saying, why does that help me? You just made it even more complicated. I'm going to put the -1/2 out front. But now you have all u's. So however you want to do this problem, you have polynomials. So it doesn't matter to me how we split this up. I would say let's keep our -1/2 out here. And then distribute. If you want to distribute the u to the 1/3, or you can combine this into one term or split this fraction up. I mean, you got so many choices. I might just split that fraction up first. So this is -1/2 u. 7 plus 3/2 is 8.5, just 17 halves. And we're multiplying that all by u to the 1/3. Don't worry, it's getting nicer. So I'm going to distribute. Still haven't integrated yet. So I have -1/2 u to the first times u to the 1/3 is u to the 4/3 plus 17 halves u to the 1/3. Now, I'm sure you would have caught that du being gone. Now I just integrate. It's just a polynomial. Raise it by 1, divide by the power, raise it by 1, divide by that power. So double substitution, don't be afraid. It's not going to hurt you. We won't finish this problem on this video, but that helps you with getting some u-substitution reteaching if needed.